November 121 Mike, your turn. Taxiing 111.
Hi, and welcome to 121 Point Mike Ground School. I'm Mike Thompson. This video is part of the weather series, and I'm going to talk about clouds. First off, what is a cloud? Well, it's tiny water droplets suspended in the air. It's not water vapor, which is a gas. It's actual tiny droplets of liquid water, but they're so small they can stay up there. If they're way up there, then they're made of ice crystals, or snowflakes if you like, because snow is a type of ice, and because ice is solid water. And then, liquid snow, of course, is called rain, but we'll get to that in another video. So, that's what a cloud is, a large collection of tiny bits of water, or ice. We have different classifications of clouds too, based on their altitude or their characteristics. And you can mix and match. The low clouds go up to 6,500 feet. The middle ones go up to the mid-20s. And those are the only ones really you need to worry about when you're training. Interestingly enough, though, about half of the water vapor in the atmosphere is below 6,500. Coincidence? Go read the Aviation Weather Handbook for a ridiculous amount of info on all this. But what's with this barrier in the sky that all clouds kind of seem stuck at? When you look out, right, you can see that many times the clouds have flat bottoms, and that they all kind of start about the same altitude without any cloud daring to go lower. What's with that? Well, that is a visual representation of the dew point. We've all heard that for years, and maybe we don't really understand or consider it. So, here we go. The dew point is the temperature at which water vapor can turn back into a liquid, right? When you boil water in a pot, you add energy to it, and so it all steams up and then disappears into a gas, right? It's a vapor now. But when you have that cool glass of iced tea that starts to sweat, that's the vapor in the air being cooled by your glass to a point where it can condense back into a liquid. Dew point is just a temperature at or below which water vapor can turn from a gas to a liquid. That's why you see dew on the grass in the mornings, right? It got cold enough below the dew point overnight. Okay, so that's easy to understand. So let's go back to the cloud thing. Maybe you can figure that out now for just a second. So I'll let you think on that actually. Maybe hit pause here. You now have all the knowledge and hopefully the intuition to figure out why the clouds don't go any lower. Long pause. Because they can't, right? It's really that simple. The cloud bases are where the temperature and the dew point converge. Below the cloud bases, the temperature of all the air is above the dew point. And so the water must exist as a gas in that spot, right? It's warmer down low, it's colder up high, and the cloud base level at above, the temperature is below the dew point. So clouds can exist. Now, you're going to see this on your test, and you need to know how to estimate the height of the cloud bases. Why? Yeah, well, for VFR pilots, there are cloud clearance requirements, right? And you need to know if you can maintain them and still maintain a safe height above the terrain, right? 1,000 above congested areas and 500 above, sparsely populated areas. So there's at least a couple reasons why you need to know. But how do we have any idea how low or high the cloud bases are? The lapse rate. Luckily, down low, the air cools at a predictable rate as you go higher. Remember, it's colder up high. That's why, ski resorts are in the mountains. Snow's happier up there. You also don't go very fast if you try to ski in central Kansas. You'd need a boat for that. So, what's this lapse rate thing? Well, dry air cools at about 3 degrees Celsius per 1,000 feet, and the dew point decreases at 0.5 degree per 1,000 feet. So, the temperature dew point spread closes in at 2.5 degrees per 1,000, or 4.4 Fahrenheit. That makes the math a lot harder, so we use Celsius. So if you start at sea level, right, with standard temp at 15°C and you go up 6,000 feet, you can expect it to be very cold. So get that cabin heat on. And since temperature and dew points are given in METARS, TAFs, and the ATIS and ASOS reports, you can use this to estimate the cloud bases. So let's do one. Temperature, 1, 2. Dew point, 0, 7. What's the cloud base? Long pause. Well, the spread is 5 degrees, isn't it? 12 minus 7. And at 2.5 degrees per thousand, we can expect the temp and dew point to converge at 2,000 feet. 5 divided by 2.5 is 2. So there you go. There you go. Not difficult, is it? And now we can estimate the cloud bases with fairly good certainty. Now, clouds are given in AGL, not MSL. And this is important to remember. It's going to be on a test. They're going to try to confuse you. And you'll have to know if you can meet visual minimums for your check ride. If your airport elevation is 1250, then the cloud bases are at 3250 MSL, right? Yes. Let's do one more. Here's a METAR. What do we expect the cloud bases to be? If you don't know how to read that, go check out my video on METARs. It'll help you. But the temperature is 12 and dew point is 9. That's a spread of 3. So we divide the spread of 3 by 2.5 and we get 1.2. So that's 1,200 feet AGL. MKT is class E, so you need 500 below the clouds. And the area is not terribly congested, so you need 500 minimum altitude. But that only leaves you 200-foot margins. I'd say that's certainly marginal for VFR, so maybe don't go fly that day. Your instructor will actually test you on things like this, right? This is that practical knowledge that you need to be able to apply when you fly. Go or no go. By knowing the spread, you can estimate the cloud bases. But what if the spread's less than 2 degrees? What might you expect? Long pause. The cloud base could be near the ground, or perhaps right on it. And what do we call a cloud at ground level? Fog. That's another video, but pay heed all who enter and beware of the fog. Don't go into the fog if you're VFR. That's asking for trouble, right? So the temp dew point spread is useful, isn't it? It can help you make go, no-go decisions and predict the conditions upon your arrival. Luckily, METARs also report the cloud bases, so you don't have to do the math. But you need to know how to, and now you do. 2.5 Celsius per thousand, or 4.4 Fahrenheit. Luckily, the temps are usually given in metric to make the math a lot easier. So, that's clouds. They affect a lot of what we do in aviation, and they're really always there, even when you can't see them. So, keep an eye on that spread. But go ahead and subscribe if you haven't already. That'll certainly help me out, as we'll leave in a bunch of comments and engaging in lively discussions down below. And thanks for staying with me on 121 Point Mike.